Alright, hello everyone, hopefully you're having a wonderful night, and today I'm going to be walking you through how to solve LeetCode 133 clone graph. Given a reference of a node of a connected undirected graph, return a deep copy clone of the graph. Each node contains a value int and a list of its neighbors. So before we can go into the approach, we have to know, hey, what is a deep copy? So here on the left-hand side, we have the original graph, and we have some examples of various copies. The first one at the top would not be considered a copy because it is the same exact graph. So it hasn't been copied. We just returned the same as a graph. There's only one graph actually. The one on the bottom, while this is a new graph with new nodes, the order just isn't the same. As you can see in our original graph, 1 has neighbors of 2 and 4, but in the clone graph, 1 has neighbors of 3 and 4. This is not equal, so this cannot be considered a deep copy. And finally, we see the one in the middle. This would be considered a deep copy because these are brand new nodes with different references and they're in the correct orientation. All right. So now let's go into the approach. We're going to be using a depth first search approach for this. And what we're going to do is use a map. And the map is just going to ensure that we don't clone a node twice because there could be cycles in the graph. So we want one clone to every node. So the map will have the key of the original node reference and a value to the cloned version. All right. So what we're going to do is iterate through the graph. And if the node is not in our map, we clone it immediately. Then we iterate through the node's children and call DFS recursively on those nodes to clone them as well. And when it returns, all we do is append those to the original node's neighbors array, right? And if that doesn't make sense, that's totally fine. That's why we're going to go over it. So let's say we start DFS on node 1, and I'm going to put a star to denote that it is the original version. So let's say we have the original 1 here, and its value will be the cloned version of 1, because we're going to clone it immediately. All right, so I'm going to draw the node 1 here because it's been copied. Next, what we want to do is iterate through 1's children. Let's go to 2 first. We say, hey, is 2 inside of our map? It's not, so we're going to clone it immediately. So we have the original 2 and a copy of 2. And next we have to iterate through 2's children. 2 has a child of 1, right? That's in our graph. So that's going to return the clone immediately. We want to return the clone if it's already in our graph. All right, so we copy node 2 and we call DFS on its child 1. 1 was already in our map, so it just returns the copy. So that means that 2 is connected to 1. So we call it DFS on 1, its neighbor. It's already in our map, and that just returns the copied version, and we append that onto its neighbors, right? So now 2 is connected to 1. So 2 called DFS on 1. So now it has to call DFS on its next child, 3. Slightly different because 3 is not in our map. So we're going to create a key with the clone of 3, right? And from 3, since we have 3 created, we're going to write it right here. It's not connected to anything yet. 3 is going to iterate through its children. 3's child is 2. 2 is inside of our map, right? So that means that 3 connects to 2 because when we call DFS on 2, it will immediately return the clone. All right. So 3 just check 2. Now 3 has to go to do its next child, 4. 4 is not inside of our map. So of course we put the original as the key and we have a clone here. So we have the node 4 that's been cloned, and the same story here. We say, hey, let's iterate through 4's children. We look at 3. 3 is already in our map, so it's going to return the reference to the clone. So that means that 4 connects to 3. We did 4's first child. Now 4 has one more child, 1. So we say, hey, is 1 inside of our map? It is, so it's going to return the clone. So 4 also connects to 1. And you may say, hey, this looks like a copy. Not quite, because it is an undirected graph, so that means that the edges can be traversed either direction, and so far, this graph is not unidirectional. All right, so what happens from here? We're at 4, and 4 just traversed 2 and 3, so both of its children have been fully traversed. So now this function call ends, and we're going to return whatever was copied, right? So what node called DFS to node 4? 3, because that was 3's child. So 3 gets a return statement from 4, and 4 says, hey, I have a copy of this node, and it returns it here. So that means now 3 is now connected to 4. All right, and a very similar thing happens when we're at 3. 3 has traversed 4 and got a return statement. And we have went to 2 and connected 2, right, and got a return statement. So now this call ends, and we're going to return the node that we just copied, the 3. Who called DFS node 3? 2. So 2 is going to be connected to 3 because we returned the copy. All right, so a very similar thing happens here. 2 has traversed to 3 and got a return statement, and it traversed to 1 and got a return statement because there's 2 edges coming out from 2. So this ends, and from we say, hey, who called DFS node 2? 1. So this gets a return of 2's copy, right? And finally, we started off at node 1. We're at the top of our DFS call. We've traversed to the 2, and we never traversed to the 4. We only went to the first child and went DFS. So now we have to go to the 4. We say, hey, DFS node 4. Node 4 is inside of our map, so it just returns the copy. So 4 here that we made, and we say 1 is connected to 4. And as you can see, this would be a deep copy of the original graph because now there's an edge between all of them, just like here, and they can be traversed either direction because the graph is undirected. So from 1, we can travel to 2, and from 2, we can travel to 1. All right, I know this can be a bit confusing, especially with the unwinding of the DFS, but we're going to get into the code, and hopefully that'll help elucidate some things. All right, so the first thing I always like to do is worry about edge cases. What if they gave us a graph with no nodes? So if not node, return none. All right, so that gets that off the way. Next, we need to create our map. And remember, our map is going to just be a dictionary, and it's going to be empty at first. Now we have to create our DFS. So define function DFS, and it's going to take in, I usually would use the word node, but node is taken from the cloneGraph function, and I don't want to confuse anybody. So just think about cur is just our current node. And since it's DFS, we need a base case. So we say if cur in map return map at cur. And map at cur should just be the cloned version, right? So if it's been cloned before, we immediately return. And if it gets out past this line, that means it has not been cloned. So we need to copy it. So copy equals node, and we need to copy cur.val. So all this is doing is creating a brand new node with the same value as the current node. Just like when we were traversing up here, when 1 was not inside of our map, we created a copy, and then we appended the original node as the key and the copy is the value, right? So this is us creating a copy. So now all we have to do is add it to our map. So map at cur, which would be the original node, equals copy. So now we have it, they're linked. Now, if we query the current node, we'll get the copy. All right. Next, what we want to do is iterate through the children. So we say for nay in cur.neighbors. And now what we want to do is append the return of DFS on each of the neighbors. So we say map at cur. So map at cur will be the copy. And we say dot neighbors dot append. And what do we want to append? DFS of neighbor. And let's quickly go over what this means. So for nay and cur.neighbors, we're going over all of the neighbors in the current node we're looking at. Next, what we're doing is getting the reference of the cloned node. So if we just cloned 1, this will be the clone of it. And right now its neighbors is empty, so we have to fill it up with the cloned versions. And we say dot neighbors dot append. So this is adding it. And we're going to add DFS at neighbor. And if neighbor is already in our map, it will return the clone and we'll append the clone from it, right? Perfect. And once they get out of there, we just need to return copy. And the return copy is, remember when it was unwinding? Once 4 called DFS on 1 and 3, all of its neighbors, it has to return what we copied to whoever called it. 3 called DFS on node 4, so we have to return the node 4 or copy of node 4 to 3. And that's what the return copy does. Now all we have to do here is return DFS at node, and node is just the original, the entry point in our graph. So let's submit it and see how it goes. And there we go. We passed, and it's relatively efficient. If you have any questions, comments, concerns, please comment down below.